In this lecture, we will be talking about the setback distance and the curve resistance and solve some problems from gate. And if you didn't subscribe to my channel, please go and subscribe and press the bell icon for my latest updates. So let's start. Suppose you have this type of curve, and now what happened? Suppose one vehicle is coming from this side and another vehicle is coming from this side, and मान लो ये ड्राइवर इस वाली गाड़ी को देख रहा है, and this is really important, then that one another vehicle must be in the line of sight from that upcoming vehicle from opposite side. और ये जो दो ड्राइवर है ये दोनों एक दूसरे को देख सकें, वो कितनी होनी चाहिए डिस्टेंस? दैट शुड बी इक्वल टू SSD. दिस डिस्टेंस इज इक्वल टू SSD. तो यहाँ पे जो बिल्डिंग तुम्हें बनानी है, दिस बिल्डिंग, दैट मस्ट नॉट बी लाई बियॉन्ड दिस पॉइंट. इस लाइन से आगे नहीं बना सकते, अदरवाइज ये वाला जो ड्राइवर है इसको नहीं देख पाएगा अपकमिंग व्हीकल को. तो ये जो भी रोड की सेंटर लाइन होगी, दिस डॉटेड लाइन, दिस सेंटर लाइन होगी, यहाँ से लेकर यहाँ तक उसको बोलते हैं सेटबैक डिस्टेंस. दिस डिस्टेंस विल बी इक्वल टू दिस सेंटर लाइन टू दिस पॉइंट. दिस डिस्टेंस इक्वल टू setback distance. So setback distance means you cannot construct the building beyond this line, otherwise SST आप provide नहीं कर सकते. And how to evaluate the setback distance? Now, there are two cases for setback distance. The first one is that the length of curve should be greater than stopping side distance, and the another case we can evaluate the setback distance is that the length of curve should be less than SSD. Now let's talk about the case 1, that is length of curve is greater than SSD. Suppose this is any curve and this is the length of curve and these are the vehicles, and this is the visibility between the two vehicles, and this is the center line of this pavement, and this is SSD, stopping side distance of these vehicles, and this is any obstruction or building. So what is the setback distance? As I have told you earlier, this distance from the center line of this pavement to this point is the setback distance, and this is the case when length of curve is greater than SSD. As you can see, this is the length of curve and this is SSD. So length of curve is greater than SSD. Now, if we see the geometry of this single lane pavement, suppose this is the curve and this is the center line and these are the vehicles. So geometrically, if we see, suppose this is the center of this curve and this distance is the setback distance, this is the obstruction, this is the setback distance, suppose this is M, and if this angle is alpha, then this will be alpha by 2, and this is the radius of this curve R, then geometrically this distance will be R cos alpha by 2, and this distance is R, again the radius of circle. So what is the setback distance? The setback distance for this single lane pavement will be, or we can denote it as M, equal to R minus R cos alpha by 2. If we subtract this R cos alpha by 2 from this R, we get this distance, and this distance from the center line of this single lane pavement to this obstruction is the setback distance. Now let's see the case for 2 lane or more lane pavements. Suppose these are the vehicles from this side and this is the vehicle from opposite side, and this is the center lane of pavement, and this is any obstruction or building. So the setback distance in this case will be from this inner lane to this is the setback distance, and this will be the radius of this curve. And suppose this distance from the center line of this pavement is D, and this will also be D. Same in this case, this distance will be D and this distance will also be D. And if this angle is alpha, then this angle will be alpha by 2. And geometrically, if we calculate this distance will become R minus D, and this distance will be R minus D cos alpha by 2 geometrically, and this distance is R, again the radius of circle. So for 2 or more lanes, the setback distance will be, if we subtract this R minus D cos alpha by 2, as this distance is D from from the center line of the single lane pavement or inner pavement, this distance is R minus D. So if we subtract this R minus D cos alpha by 2 from this R, we get this distance. So the setback distance in this 2 or more lane case will be M equals to R minus D cos alpha by 2. And now if in question it is asked that calculate the setback from the center line of this inner lane. So for center line, how we can calculate the setback? R minus T minus R minus T cos alpha by 2. So the setback will be R minus T 1 minus cos alpha by 2. सिंगल लेन पेवमेंट के केस में हम क्या कर रहे थे, हम सेंटर लाइन से जस्ट रेडियस कंसिडर करके ज्योमेट्रिकली हमने ये डिस्टेंस निकाली R cos अल्फा बाई 2, और हमारा सेटबैक क्या हो गया, ये डिस्टेंस R हमने इसमें से माइनस कर दिया, तो हमारा सेटबैक कितना आ गया R माइनस R cos अल्फा बाई 2। और 2 और मोर लेन्स के केस में क्या हो गया, हमने ये डिस्टेंस क्या है हमारा, जो हमारा आउटर एज था इनर लेन का, उस वहाँ से हम रेडियस कंसिडर कर रहे थे, तो इस केस में हमने क्या करा, R माइनस टी कॉस अल्फा बाई 2 को माइनस करा, तो हमारा ये डिस्टेंस आ गया। अगर क्वेश्चन में कह रहा है कि हमारा जो सेटबैक है हमको कहाँ से निकालना है, सेंटर लाइन ऑफ इनर लेन, तो इस केस में क्या करा हमने, R माइनस डी ये डिस्टेंस को कंसिडर किया, R माइनस डी कॉस अल्फा बाई 2। सो दिस इज द सेटबैक। Now one more thing I wanna tell you is that how we can calculate this alpha angle or alpha by 2 angle. So as this is the property of circle, suppose this is any radius, this is any circle and this is the radius, this is the center of this circle and this angle is theta. So this distance will be, this length of curve or distance, this is the length of curve, this length of curve will be equal to r theta by the property of circles. And similarly this case is applied to this, if we apply on this, as this is the SSD, this distance is SSD. So if we apply this property on this geometry, on this single lane pavement, what we get the SSD means this distance. So this distance will be, suppose in this case this distance will be, let me draw first, suppose this is the single lane pavement So by the by the property of circles, we can calculate this SSD, and this SSD will be equal to, we get SSD as R minus D, as I am considering for two or more lanes. So SSD will be equal to R minus D alpha, this angle. If we apply this property of circle on this, we get this distance SSD. This SSD will be equal to R minus D alpha, like this. So we can calculate alpha from this. We get alpha as SSD upon R minus D, or we can and we get this alpha in radians. And if we calculate this angle as alpha by 2, what we get, alpha by 2 will be equal to SSD by 2 R minus D simply. And if we need to calculate it in degree, what we need to do, we need to multiply it by 180 by pi. So we get this alpha in degrees. Now consider the second case. The second case 2 will be length of curve is less than SSD. How we can calculate? By length of curve is less than SSD. Let me draw first. This is the pavement. I am considering for two or more lanes. Suppose this is 2-lane pavement, and this is the center line of inner lane. Suppose this angle is alpha, so this will be alpha by 2. Suppose these are the vehicles, and this is the length of curve, and the vehicles are somewhere here. So this distance will be SSD. So in this, length of curve is less than SSD, and also considering this distance, and this is any obstruction. So in this case, the setback distance will be from this inner lane to this obstruction. This distance will be setback distance. So the setback distance in this case will be M equals to, suppose this is M, and we have calculated earlier this distance as, suppose this distance is M1 and this distance is M2. So the setback distance in this case will be M1 plus M2. Suppose this is any, let's consider this is any triangle, and suppose this angle is alpha by 2, and this distance is SSD minus S. So by considering sine alpha, by applying the trigonometry on this particular triangle and calculate the value of sine alpha on this triangle, we get M2 upon, this distance is M2 upon SSD minus length of curve upon 2, sine alpha by 2, as this angle is alpha by 2, I am considering it as alpha by 2. So sine alpha by 2 will be equal to M2 upon SSD minus L by 2. M2 will be this distance SSD minus L upon 2 sine alpha by 2. So we get the setback as M equals to M1 plus M2. Now let's solve a question from GATE. This question is asked in GATE 2012. Given the length of curve as 200 meter and the radius of horizontal curve as 300 meter and the width of pavement as 7.5 meter and the stopping distance as 80 meter, and what we need to calculate the setback distance or M from the center line of inner lane. So if you see this question, in this question the length of curve is greater than SSD. So this is the case 1. As you see, length of curve is 200 meter and the stopping distance as 80 meter. So length of curve is greater than SSD. Now if we see the geometry of this is the width W of pavement, and this W is given 7.5 meter. So in this case, the setback distance or M will be equal to R minus D minus r minus t cos alpha by 2. So how we can calculate this d? As you can see, we have given the width of pavement as 7.5. So for single lane, the width of pavement as per IRC is 3.75 meter, and for two lane pavement the width is 7.5 meter. So this is two lane pavement as I have drawn. This is two lane pavement and the width is given as 7.5 meter. So if we count this d, this distance is d, this distance is d, similarly to this. So we have 4d is equal to the width of pavement, and the width is given as 7.5. so we get 4d, and we get that this distance will be 7.5 upon 4, and we get 1.8755 meter. Next we need to calculate this angle alpha by 2 is equals to ssd upon 2r minus t, and we need to calculate it into degree into 180 by pi. It will be in degree, and I have calculated before. You can calculate by your own. We get alpha by 2 as 7.68 degree approximate. So we get this angle alpha by 2. Now it becomes very easy to calculate the setback distance. R is 300 meter minus d is 1.875, and 1 minus cos alpha by 2 is 7.68 degree, and we get this setback distance as 2.54 meter. And this question is asked in for 2 marks, and the option A is correct, and this is 2.54 meter. One more thing I want to tell you is the curve resistance. This is also important topic, and it is asked in the objective type. What is curve resistance? Suppose this is our vehicle. When our rear wheels provide the push, or technically the tractive force, this tractive force T, so that force is responsible to make these front wheels keep moving, and this push force is the tractive force, and this can be denoted as D. But when our vehicle is on horizontal alignment, suppose this is any curve and our vehicle is somewhere here, these are the rear wheels and these are the front wheels, and this is the tractive force, and this vehicle is moving in this direction. So on curves, what happened? This is T and this component is T cos alpha, suppose. So on horizontal curves, what happened? When our vehicle is on horizontal alignment, then on curves, some of the components, this T cos theta, some of the components of this tractive force lost. Suppose T cos alpha is lost on this curve. In short, what is curve resistance? It is the loss of tractive force due to the turning of vehicle on a horizontal curve, and it can be denoted as T minus T cos alpha. This is the curve resistance. Means लेट मी एक्सप्लेन इन हिंदी. सपोज क्या होता है, हमारा जो रेयर व्हील्स है वो हमारा क्या करते हैं, पुश प्रोवाइड करते हैं. वो पुश और या उस पुश को क्या बोलते हैं, ट्रैक्टिव फोर्स, जो कि मदद करता है फ्रंट व्हील को ड्राइव करने में, आगे बढ़ने में. और यही व्हीकल जो है जब हमारा हॉरिजॉन्टल कर्व्स पे होता है, तो जो ट्रैक्टिव फोर्स है इसका कुछ पार्ट, कुछ कंपोनेंट क्या होता है, लॉस हो जाता है on curves, and this is defined as the curve resistance. And friends, if you find this video informative, don't forget to like, share and subscribe. Thanks for watching.